Doesn't look like she is. All right, let's rock and roll. All right, so exponential equation. Okay. Whew. That's some stuff. Alrighty, here we go. You ready? So, y equals a times b. And you were livid. Yeah, that sounds something to be upset, like something you would be upset about. All right, so check it out. Let's talk about what an exponential equation is. So an exponential equation is something with the variable, as you can see, x, right? Up in the exponent. So a really simple exponential equation is y equals 2 to the x, right? Something like that. And if we make a little chart, you can kind of see what's going to happen here. So here's our graph. Okay. Tried to learn it, tried unsuccessfully. So if x is 0, what's 2 to the 0th power? Oh boy. If we don't know what 2 to the 0th power is, we might have to start a little bit early. Or a little bit like earlier than where I'm starting. What's 2 to the 0th power, boys? Good guess, good guess, good guess. Let's talk about that. All right, here we go. Exponents are repeated multiplication, yeah? You know what 5 squared is. 5 times 5, right? No debate, no debate. Awesome. 5 cubed. Well, that's 5 times 5 times 5. There's 3 5s there. You see the connection, I hope. 5 to the 4th. Well, this is crazy. It completely goes... No, it doesn't. It doesn't go against the pattern at all. It goes with the pattern. It's 5 times 5 times 5 times 5. All right, so you could probably guess what would happen if I did 5 to the 5th, right? I'd times by another 5. I would times by another 5. So, 5 to the 1st. What's 5 to the 1st? Boys, what's 5 to the 1st? You see the pattern, right? Come on, 5 to the 1st. 5. Oh, Preston on fire. 1 for 1 right now. All right, so what's 5 to the 0th? It's not 0. Too slow, too slow, too slow, too slow. -5. Good guess. Excellent guess, but wrong. -5 doesn't follow the pattern. It's a good thought. It's a good thought. What is the pattern? What do I do to get from here to here? Think about it mathematically. What did I do to get from here to here? 2.5. Good guess, but nope. 2.5 because you're dividing by 2 each time? I'm not dividing by 2. Am I? What am I doing to get from here to here? Let's talk about what happened from 4 to 3. 5 to the 4th and 5 to the 3rd. What am I doing? Nothing. You can't do it. Nope. You can. It's a good thought. It's a good thought. How did I... When I went from 4 to 3, the same thing should happen when I go from 1 to 0, right? So what did I do when I went from 5 to the 4th to 5 to the 3rd? Think about that. I got rid of a 5, right? Well, how did I get rid of a 5? Think mathematically. What did I do to get rid of that 5? That's what I'm talking about, Shambot. We divided by 5, right? To get from there to there. Because it's times 5. To get rid of that times 5, I divide by 5. Just like when I go up, I times by 5 when I put another 5 here, right? Well, when I divide by 5 here, and divide by 5 here, I get to here. So what's 5 to the 0th? Close. It's 5 divided by 5. That's what I've been saying. Guys, Abigail just said, is that why 5 to the 0th is 1? Well, of course. She's like, well, I was just told to memorize that. Now you know why. It makes sense. It does follow the pattern. We keep dividing by 5. Right? We're not taking away a 5. That'd be subtracting, right? What we're doing is we're dividing. So it's 1. In fact, anything to the 0th power will be 1 because 5 to the 1st is 5. We divide by 5 and get 1. If I did 10 to the 1st, I get 10. Well, to go back, I'd have to divide by 10. I get 1, right? Anything to the 0th is 1. All right. Oh, okay. We're feeling good. We're feeling fresh. We're feeling great. Awesome. Fantastic. What would 5 to the negative 1st be? Where are your gods now? Where are your gods now? Negative 5. Good guess. But no. Not negative 5. How do I go down one step? What do I do? Well, we're dividing by 5, right? Tell me 1 divided by 5 is negative 5? You got another thing coming, boy. We're dividing by 5. What do we do? Think, men, think. 1 divided by 5 is 5? Divide by 5. Gentlemen, fractions are division for lazy people. What's 1 divided by 5? 1/5. It's 1/5. Fractions are division for lazy people. What's 1 divided by 5? 1 over 5. What's 7 divided by 3? 7 over 3. What's 100 divided by 9? 100 over 9. Fractions are division for lazy people. I don't know what 1 divided by 5 is. It's 1 over 5. It's 0.2. Who cares? No one likes decimals anyway. It requires a calculator 9/10 of the time. So, it's a fifth. Does that make sense? We keep dividing by 5, right? Are we good up to here? Are you smelling what I'm stepping in, boys? Do you smell what the rock is cooking? I need that on my soundboard. I need that. Guys, I want to wear these, but like I don't think they're the right prescription because I can't see out of them very well. Of course. Of course. KFC. All right. Divide by 5 again, right? I got another lesson for you. Fractions are division for lazy people. Division is just multiplication done on the bottom. You get it? Multiplication done on the bottom. You know what I'm talking about? Multiplication done on the bottom. You smell what I'm stepping in here? A fifth divided by 5 is just multiplying on the bottom. 1 over 25. Which means 5 in the negative third would be 1 over 125, because 25 times 5 is 125. 25 times 4 is 100, right? 25 times 5 is 125. It's on the bottom. Multiplication is division is multiplication done on the bottom. You smell what I'm stepping in? We cool with that? So 5 to the 0th is, of course, 1, because we keep dividing by 5, right? Negative 3? Okay, great. We divide by 5 3 times. Go from here to here. Oh, yeah? So, 5 to the first, you might notice is 5. 5 to the negative first is 1 over 5. So there's another pattern that's going on here. That's not why it is what it is, right? The reason it is what it is because we divide by 5 when we go down. We multiply by 5 going up, right? From 5 times 5 to 5 times 5 times 5 times 5 times 5 times 5 times 5, right? We always multiply by another 5 when we go up. We divide when we go down. But there's also another pattern. 5 times 5 is
125.
And this is 1 over 125. It's the reciprocal. It's the flip, right? So as soon as we go negative, what we're doing is the same thing we did up here, but we're flipping it. 5 becomes a fifth. 5 squared is 25, so 5 to the negative second is 1 over 25. Okay? All right? How we feel about that? How we feel about that? Got it. Good. Say that again. Okay. So another pattern you might notice. 5 to the first is 5, right? 5 to the negative first is 1 over 5. 5 squared is 25. 5 to the negative second is 1 over 25. So it's just another pattern. But again, when we go down, we're dividing by 5. If we go up, we're timesing by 5, right? For the pattern, right? Okay, cool. Let's talk about what happens. X is 0. We have 2 to the 0th. What is 2 to the 0th? Juan. It's Juan. So if I want to graph this guy, right? When I plug in 0 for x, I get 1 for y. 0, 1, right? If I plug in 1 for x, what's 2 to the first? What's 2 to the first? Oh, God. If I plug in 0 for x, I get 2 to the 0th, which is 1. If I plug in 1 for x, I get 2 to the first. What's 2 to the first? Thank you. So 1 comma 2 is what I get. 1 comma 2. Oh, he's getting ahead of the game. 2 squared is 4. Oh my God, it's Jason Bourne. Oh my God, it's Jason Bourne. You can see the shape of this, right? What happens if I plug in -1? I'm not going to use my chart. What happens if I plug in -1 here? What do I get, boys? What do I get if I plug in -1? A half, yeah. Way you're going to show that is 1 over 2. There you go, there you go, there you go. So when I plug in -1, I get a half. What happens when I plug in -2? What happens? Division is multiplication done on the bottom. What happens when I plug in -2? 2 to the negative second. Division is multiplication done on the bottom. A quarter. Very good, very good. Now, will this ever get to 0? I'm taking half of a half, I get a quarter. Half of a quarter, I get an eighth. Half of an eighth, I get a 16th. Half of a 16th, I get a 1/32. Will this ever reach 0? Heck no. Heckin'. No, it won't. It won't. So there's our graph. It gets really, really close to 0, but never actually crosses it, does it? It never dips below this line. This line is called the asymptote. I'm not joking. I am not joking. It's pronounced asymptote. Asymptote. This is not a joke. I know, right? It's the asymptote. The bottom tote? No, you have to say ass. It's wrong if you say button tote. It's the asymptote. So the line that it never crosses, that's the asymptote. You know how there's some rules you just don't cross? There's some lines you just don't cross. That's an asymptote. That's an asymptote. So this one has an asymptote at 0, right? It never goes below 0. We can get really close. A half, a quarter, an eighth, a 16th, right? Asymptote? Idiots. All right. Asymptote. If you have the opportunity to call it an asymptote or an asymptote, what are you going to call it? 9 times out of 10. 100, 10 times, 50 times out of 50, I'm going to call it an asymptote. 50 times. That's 100% of the time. That's 100% of the time. We keep it cash. All right, so this is an asymptote. Asymptote at 0. So horizontally speaking, this guy goes all the way to the left as far as he wants, and he goes all the way to the right as far as he wants, because it looks like he's going straight up, but he's not. He's slowly moving to the right, okay? He just goes up really fast. But it is going to the right still. So left to right goes on forever, okay? We call that the domain. The domain of something is how far it goes left to right. That's the x, right? Left to right is x, up and down is y. So x can be any real number. That's what this means. X exists in the real number. So any number you want can show up here. 1, right? We plug in 1 for x, we get a number. Plug in 2 for x, we get a number. Plug in 3 for x, we get a number. -1, we get a number. 0 for x, we get a number right here. Pi, 3.14 whatever, we would get a number, right? So x can be any number. Okay? Squiggles. The range, however, is the y values that can show up. Now, y can be any number you want, except this thing goes up as far as it wants, but it doesn't go down as far as it wants. What can it go below? What can't it go below? What can't it go below? 0, thank you. So it can be any number at once as long as that number is bigger than 0. You smell what I'm stepping in. The booty tote, that's right. It can go up as much as it wants, but it can't go below 0. So the up and down, any number you want, except it has to be bigger than 0. That's it, baby. That's the domain and range. That's it. That's how you would graph that function. That's an exponential function. Let's talk about it. Look familiar? Does that look familiar? You like what you see? So, graph each function. Okay. And state the transformations from the parent function. What? Provide the domain, range, and label 3 points. Okay. So, label 3 points. I'm going to do 0, 1, and 3. When I plug in 0, what's 2 to the 0th? Hello? Thank you. 2 to the 0th is 1. So when I plug in 0, I get 1. What's 2 to the 1st? Try again. 2 to the 1st. 2 to the 1st. Yep, there you go. 2. 2 squared. Oh, he's ahead of the game. Oh my god, it's Jason Bourne. All right. It's delayed. You're delayed. Okay, so, yep, all we need was 3 points. Calm down. Now, we know this never can drop below 0, right? Because 2 to the negative first is a half, 2 to the negative second is a quarter, etc., right? So, it's never going to drop below this line. Do a dashed line to say no thank you. That's the asymptote. When I draw it in, I'm going to get really close to 0, right? Because the numbers get really small. But they never actually touch 0, right? We get like 1/32nd, 1/64th, 128th, right? Gets really freaking close, but never actually touches it. That's kind of cool. That's like when you got your stepbrother over. No, I'm not touching him, right? That's what it's like. You get really freaking close and you're never touching him. Asymptote. Okay. So, domain and range. Domain. X can be any number at once, right? Period. Left and right, far as it wants to go. Goes as far as it wants to go left to right. This is still going to the right, okay? Range. Y can be any number at once. However, it has to be greater than 0. Hey, hey, hey. Perkins with the late night math review. Dude's freaking done with school, graduated, doesn't even go to this school. Still shows up for this like a freaking nerd. I'm stuck. Preston, are we good? X can be any number at once, left to right. Domain Y can be any number at once as long as it's bigger than 0, right? Y is the up and down. Got it. Good. All right, so label 3 points, they're on there. If you want to write them out, go for it. 0, 1, 1, 2, 2, 4, right? All right, parent function. They are. So, asymptotes often produce interesting limits. From the parent function. This is the parent function. There's no changes. No changes, okay? That's the parent function. Cool? Let's look at number 4. What? Oh my god, it's the same thing. It's the same thing, except it has a +2 on the end here. Let's find out what happens to that, shall we? All right, let's pick 3 numbers off the top of my head. 0, 1, 2. What happens when I plug in 0 here? Well, I get 2 to the 0th. What's 2 to the 0th? 1. Add 2 more. 3. So when I plug in 0, when all is said and done, I get 3. 0, I get 3. Okay, okay, you following me there? You smelling? You smell what I'm stepping in? You understand what I'm saying? 0 gets 3. Hello? 2 to the 0th is 1. Add 2, I get 3. Boom. Whoa, my god. It's so close, I can almost taste it. Yeah. Oh, this yellow popsicle really hits the spot. 0 gets 3. If I plug in 1, what's 2 to the 1st, gentlemen? What's 2 to the 1st? Hell yeah. Nope. What's 2 to the 1st? 2 to the 1st would be what? When I plug in 1. 2, thank you. Then I add 2 more and I get what? Thank you. When I plug in 1, I get 2 to the 1st, which is 2, plus 2, which is 4. So at 1 gets me 4. Okay, okay, okay. Hey now. Plug in 2. You're getting all confident on me. What's 2 squared? 4. Add 2, we get 6. Let's check the numbers you listed. Is there a 6 on there? Oh, appears not. 0, 1, and 2. 0 gets 3 because we get 1 plus 2. 1 gets 2 plus 2, which is 4. 2 gets 4 plus 2, which is 6. Now, what if I did -1? 2 to the negative 1st is a half, right? A half plus 2 is 2.5. So I'm like at 2, but a little bit more, right? Something like that. What if I do -2? 2 to the negative 2nd is a quarter, right? So I get 2.25. Do you see how it's never going to touch 2? Like last time it never touched 0, right? Because it went from a half to a quarter to an eighth to a 16th, right? This is 2.5, 2.25, 2 and a 16th, 2 and a 32nd, 2 and a 64th, right? It's never going to pass 2. So our asymptote is now here. Asymptote. So our graph is the exact same graph as before, except what? Here's our graph now with the +2 on the end. Here's our graph from before. What happened? What happened? It's the same graph except what? It stops at 2. Right, it's 2. We took the whole thing and moved it up. Right, exactly. 2 ways of looking at it. We moved the whole thing up. So the asymptote was on 0 and now it's on 2. Right, that's what Shamba said. And then the whole thing moved up with it, right? It's the exact same freaking thing. Okay? Wait, Olivia's here? No, you're not. Okay, so if you're here, Olivia, leave me a message. So we're supposed to list domain and range, right? Domain. X can be any number at once. Right? It goes left to right as far as it wants. The range. Y can be any number at once, except what? It has to be what? Can't go below what? Has to be bigger than 2. That's the domain, that's the range. Olivia! Awesome. Okay, so Olivia, check it out. I'm going to catch you up real quick. We're talking about exponents. 5 to the 0th is 1. Why? Because 5 to the 1st is 5. 5 squared is 5 times 5. 5 cubed is 5 times 5 times 5. Do you see how to get from here to here, I had to get rid of a 5? Well, how do I get rid of a 5? Well, that's times 5, so I must have divided 5 to get here, right? And if I divide 5 again, I get here, 5 to the 1st. If I divide 5 again, 5 to the 0th must be 1. Because 5 divided by 5 is 1. 5 to the negative 1st must be a 5th. Because I keep following the pattern, keep dividing by 5. 5 negative 2nd must be 1 over 25. Because division is just multiplication done on the bottom. So when I divide a 5th by 5, I'm going to multiply the bottom. 1 over 25. Divide by 5 again. Division is multiplication done on the bottom. 25 times 5 is 125. Are we cool with why 5 to the 0th is 1? Are we cool with negative exponents? Olivia, how do we feel about this? Hello? Hello? Not so good or good? Yellow? All right. Look at this stuff. Isn't it neat? Wouldn't you think my collection's complete? So here's a graph. Y equals 2 to the x. If x is 0, then we have 2 to the 0th, which we know is 1, right? 2 to the 0th is 1. Anything to the 0th is 1. So when I plug in 0, I get 1. If I plug in 1, I get 2 to the 1st. That's 2. So I plug in 1, I get 2. Plug in 2, I get 4, right? Because 2 squared is 4. So I plug in 2, I get 4. If I plug in 3, I'm going to get 8, because 2 times 2 times 2 is 8. Thank you, Anna. Now, what happens if I plug in a negative number? Well, negative 1 gets me 2 to the negative 1st. Well, that's a half. 2 to the negative 2nd is a quarter. Do you see how I get closer and closer to 0? We're doing exponential functions. We get closer and closer to 0, but never quite get there, right? We keep getting smaller. We start out at 2, then we get 1, then we get a half, then we get a quarter, then we get an eighth, then we get a 16th, then we get a 1/32nd, right? Do you see how it gets smaller and smaller, but never crosses 0? This line is the no-go. You don't go past this line. We call that the asymptote. I'm not joking. Asymptote is what that's called. Okay? So I have to draw that in to show it gets really close to 0, but never quite touches it. Are you cool with that, Olivia? She on that McDonald's internet. I understand. My mom called me a dork. Is she watching? Oh no. Oh no. Okay, awesome. I'm doing a 24-hour stream. All that I do is null and void. All right, so the domain is how far we can go left and right. How far does the blue curve go to the left and the right? Well, to the left, it goes on forever. And to the right, it looks like it's going straight up, but it's not. It's actually leaning a little bit. It's leaning, okay? So it goes to the right a little bit. So it goes forever to the right and goes forever to the left. It just goes faster to the left than it does to the right. So it can be any number. Oh my gosh. The range is how far it goes up or down. Well, notice it goes up forever. So y can be any number, except we know it can't go below 0, right? So it has to be bigger than 0. Are you smelling what I'm stepping in with this? You were sort of here when I taught this first quarter, or first semester. Domain and range. Left to right as far as we want, up and down as far up as we want. Can't go below 0, so it has to be bigger than 0. Are you smelling what I'm stepping in? What if my head was this big and my body was this small? How about that? Olivia, we good with this? Like not this, but like this? Okay, awesome. All right. So it looks familiar, right? That's the graph we just talked about. Whoop! Doesn't go past this line. Asymptote. Has to be bigger than 0. Now look at this graph. That's y to this, y equals 2 to the x. Whoa, not that. Don't look at that. Y equals 2 to the x plus 2. It's the same graph, but look at it. What happened to it? I'm going to do a fliporama. Same graph, except what? Except what? What happened to the graph? What happened to it? It's now what? What happened to the graph? It was here. Now it's here. Was here. Now it's here. I feel like I'm at the optometrist. Number 1 or 2. 1 or 2. 3 or 4. Yeah, a little bit. So Olivia, it's the same graph. It's just up 2, right? See how everything moved up 2? That's all that happened. That's what this does to it, the number on the outside. It makes it go up 2. Yeah, exactly. Yep. Yep. Just got to keep track of the McDonald's internet. All right. So it's the same domain and range, except now instead of it can't go below 0, it has to go above 2, right? Everything is above 2. Shamba. Preston. Are you present? Because we're ready to go. We're ready to rock and roll. I've caught her up. All right, here we go, boys. All right, so the number on the outside here, it shifts it up and down. We call that the vertical shift. So here's our formula. We have some number being taken to the x power. Don't worry about the c, right? The d, what does the d do? Well, it goes up and down. It's a vertical shift. The d goes up and down.
That's what she said.
You cool with that? So it moves everything up 2. If that was a -2, it would move everything down 2. What would our asymptote be if it was a -2 here, do you think? What would our asymptote be? If this was a -2 instead, what would our asymptote be? Yeah, exactly, -2. It couldn't go below -2, right? It shifts everything up and down by that. Awesome, okay. So we also are supposed to talk about what is the difference between the parent function. Well, the parent function is the basic one, right? Y equals 2 to the x. So the transformation we did here is this is a vertical shift, right? Shifts it up and down. The d goes up and down. And so it shifts it by 2. moves up 2, right? That's what this guy does because it's a +2 on there. So that's the transformation it did. So what did we need for the directions? We needed the transformations, done. Provide the domain and range, done. Label 3 points. Yeah, good enough. How do we feel about number 4? How do you feel about number 4? Anyone other than Anna? How do you feel about number 4? Good. Here's what I want you guys to do. Before we move on, there's a lot of delay. Okay? A little confused. Okay. I'm gonna do this with Olivia real quick, and then we're going to do something, okay? So the parent function is when it's just bare bones, right? See how it's just something to the x? Okay? Because of the +2, it took the same function and moved it up 2. Okay? That was the transformation. Okay? It transformed it up 2. Same graph, just 2 higher. Domain is how far it can move left to right. The blue line can go far as left as it wants, and as far to the right as it wants, because this does go up to the right. Also, the range is how far it can go up and down. Well, the blue can go up forever. It just can't go down forever. It stops at 2, right? So it has to be any number as long as it's greater than 2. Olivia, did that help? That's all we needed here. Transformation, graph it, domain and range. Do we see how it's related to this other function, right? We call that the parent. And then this is related to it because it's the same thing but +2. Do I have you at like 75%? Kinda? Okay, alright. We'll do some more examples. Here's what I want you guys to do. I want you guys to close your app, whatever it is on Twitch that you're viewing me on. Close it, and then, listen, and then what I want you to do is when you come back, type 5 in the chat. Put a 5 in the chat so I know you're back. And that should cut down on the delay. Do that and we'll keep going. But you're already back? Oh my god. You completely closed it out. Wow, Preston was racing. You're a funny kid. Alright, Olivia's back. ShamWow, where you at? Okay, awesome. Let's look at the next one. Let's look at number 5. So this one doesn't have a number on the outside, right? It has a number up here. Let's see how that's going to affect our graph. Okay? So if we plug in 0, right? If I plug in 0 for x, 0 minus 1 is -1. What's 3 to the negative first? 3 to the negative first power. Well, 3 to the 0th is 1. Then we divide, right? So if I plug in 0 for x, 0 minus 1 is negative 1, right? Ooh, close. 3 to the negative first. That's the negative second. Shamba. There you go. Wait, hold on. Not negative 3. You gotta remember it flips it too. Right? Here, let me show you. Right? 5 to the first is 5. 5 to the 0th is 1. 5 to the negative first is 1 over 5. See how we keep dividing? So 3, 1, 1/3. 3 to the negative first would be 1/3. Okay? So when I plug in 0, I get 3 to the negative first, which is 3, but flipped, right? 1 over 3. So when I plug in 0, I get a third. When I plug in 1, 1 minus 1 is 0. What's 3 to the 0th? Yep. So when I plug in 1, I end up getting 3 to the 0th, which is 1. When I plug in 2, 2 minus 1 is 1. So I end up getting 3 to the first. So when I plug in 2, I get 3 to the first. What's 3 to the first? Close. It's not 3 squared. It's going to be 3 to the first. 3. So Shamba, don't forget, we have to subtract 1 before we do the power. I think that might be what's screwing you up. When I plug in 2, I get 2 minus 1, which is 1. So that's 3 to the first, which is 3. Okay? I plug in 2. 2 minus 1 is 1. 3 to the first is 3. Okay? If I keep going, if I plug in 3, 3 minus 1 is 2. I get 3 squared. So 3 gives me 3 squared, which is 9. If I do negative 1, I get 3 to the negative second. That's 1/9. So I keep getting really close to 0. So it looks like our asymptote is here. Right? It won't go below here. It keeps getting smaller and smaller, but not quite past 0. It doesn't go negative, right? Now, what would our regular graph look like? The parent graph. Well, the parent graph would look like this. This is what Shamba was doing. Forgetting about that minus 1. Well, the parent graph would look like this. When I plug in 0, I get 1. When I plug in 1, I get 3. When I plug in 2, I get 9. So it still has an asymptote here, right? But look at this graph versus that graph. Do you see how at 0 I got 1? But here, 1 I got 1? What it did was this number right here moved everything to the right. So it took this and shifted it 1 to the right. So the negative 1 here made it move 1 to the right. All right? Instead of 0 getting me 1, 1 gets me 1. Instead of 1 getting me 3, 2 got me 3. Instead of 2 getting me 9, 3 now gets me 9. It shifts everything over 1. So this is our horizontal shift. Horizontal's left to right. Fair? It shifts everything over to the right one. How do we feel about that? Are we completely lost? How are we feeling? Brain hurts a little? Got it? You can always graph it by plugging in numbers, right? That's what I did to graph this. But another way to think of it is the easy function, y equals 3 to the x, looks like that. This one's moved 1 to the right. Yeah, Olivia, I gave them a crash course earlier on and went slower. I'll try to go slower and make sure I can catch you up, because you just tuned in. So, on our regular graph, when I plug in 0 for x, I get -1 here. Here, let me zoom in. So if I plug in 0 for x, right? 0 for x. 0 minus 1 is -1. 3 to the negative first is a third, right? Does that make sense? Do you know why 3 to the negative first is a third? Is that where we're getting confused? Okay. So on my graph here, I get 0 comma a third, right? If I were to plug in 1, that's 3 to the 0th, right? 1 minus 1 is 0. So 3 to the 0th is what I get when I plug in 1. So when I plug in 1, I get 1. Etc., etc. Are we good up to there? Do we understand how I graph this? Okay. So the parent function is just the basic function, right? See how that has an extra -1 on there? I just did the basic function. Y equals 3 to the x. When I plug in 0 for this one, I get 3 to the 0th, which is 1. So 0 comma 1 is what I get. Now notice 0 comma 1 is what I get here on my original, right? But it takes me one extra number to get 1 over here, right, for this guy. So 0 gets me 1 here, but on here 1 gets me 1. So it shifted everything over to the right one. It used to be that 0 gets me 1, now 1 gets me 1, right? It used to be that 1 got me 3, because 3 to the first is 3, right? But now 2 gets me 3. And it's because of that number right there. Now it's weird because you'd think 3 to the x minus 1, you'd think, oh, -1, it's going to shift it to the left. It's the opposite. It's the opposite. So what it does is it shifts everything to the right one. It's the same graph here, but it's moved to the right. That's not going to change the asymptote, right? The asymptote's still going to be here. It just moves further to the right, but again, it goes on forever, so we don't see any change. But that's the only difference. How do we feel about that? Okay. It's not as hard as it looks like it should be, right?
That's what she said.
So, what's the domain? Well, x can be any number at once, because we can go left to right as far as we want. What about the range? Well, y can be any number at once, except what can't y go below? Y has to be greater than what? So left to right, it can be anything. Are we cool with that? Because it goes to the left forever and it goes to the right forever. Are we cool with that, Olivia? So x can be any number at once. Y can also be any number at once, right? Pi shows up, all these numbers, right? Except Notice that our graph, the blue line, it never ever goes below what number? It never goes below 0, right? Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Here's 0. It can't go below 0. So y has to be greater than 0. Any number as long as it's bigger than 0, right? No negatives show up. Are we cool with that? And it never quite touches 0. It just gets really close to it. Because it goes from a 3 to 1 to a third to a ninth to a 127th, right? To a 181th. It just gets really, really tiny, but never ever crosses 0. Are we golden on that? Are we feeling okay? Anna's good. Preston, Shambaugh. Awesome, awesome, awesome. Thanks for being honest, Olivia. I'm guessing it was something real small that you were confused about and ended up causing a huge issue. Preston, Shambaugh, we good? Is Shambaugh still in the potty? There's no internet in that bathroom? Ah. Preston, Shambaugh, status report. Oh my god. Aberman, I can't believe you're sitting through this. This man's sitting through more than these guys are. So, it turns out that this right here is our horizontal shift. It's the opposite of what it says. If it's minus, it's plus. If it's plus, it's minus, right? It moves left to right. Kind of like our H and K. Hi, Lily. Boys, where'd you go? Now to mark them down. Yikes, that's not good. Let's make sure they're not texting me and saying their internet went out or something. Nope, doesn't look like it. Emailing me? Nope. Uh-oh, this is not good. Preston Shambaugh, what the... Oh, no. Alright, well, I'll mark them down. And they'll have to pick up where they left off. I'll keep going for Olivia. So we left off at question 5. Question 6. All right, so let's talk about this. First of all, vertical shift, right? It's going to move everything down 1. So our asymptote is going to be 1 lower, right? So now it's going to be at minus 1. And it's going to shift our parent function over to the right too. So, Olivia, one way to graph this is to plug in numbers and see what happens. That's totally fine. That's totally fine. Another way is to do this. Think of the parent function. Olivia, when I plug in 0 to the parent function, I get 1, right? When I plug in 1, I get 2. When I plug in 2, I get 4. When I plug in 3, I get 8. Right? So that's what it would look like if I graphed that. Now, what does this do? Well, it moves it 2 to the right, and it moves it 1 down, right? Are we good up to there? That's what the basic one would look like. This is going to move it 2 to the right and 1 down. You with me? All right, awesome. So again, could you just plug in numbers and see what happens? Sure. I think that's not very fun and a lot harder to do. So I'm going to take these numbers and I'm going to move them 2 to the right and 1 down. Well, normally I'm at 0, 1, right? 0, comma 1. If I move 2 to the right, 1, 2, and 1 down, now I'm here at 2, 0. Normally I'm at 1, 2, 1, comma 2. If I move 2 to the right, 1, 2, and 1 down, now I'm here at 3, 1. Normally I'm at 2, 4. 1, 2, 1, 2, 3, 4. But if I move 2 to the right and 1 down, now I'm at 4, 3. You see my graph? Now I know I can graph more points, but I only need 3 for this quiz. So here's what I'm going to do. I know it can't go below -1, right? Because that's my asymptote, right? It moves everything down by 1. So I know I can draw really close to there and then start curving up. And there's my graph. That's a lot easier than plugging in 0, getting -2. 2 to the -2 is a quarter. A quarter minus 1 is -3/4. So I'm going to go -3/4. Right? Don't do that. Think in transformations, right? It's the same as this guy, but 2 to the right and 1 down. How do you feel about that? Preston, you're back? Oh. Yeah, Tyler's taking a poopy. That's okay. Good, I guess. Okay. Man's got to do what a man's got to do. No internet in that bathroom, apparently. There used to be, and his mom took it away. All right, so that's the graph. Now, what's the domain? X can be any number, right? It goes left to right as far as it wants. The range. Y can be any number, but it can't go below what? It has to be above -1, right? Can't go below -1, so it has to be above -1. What more do you want? What do you think? That's it. We spent 2 weeks on this. How did we spend 2 weeks on this? Get out of here with that crap. Y equals mx plus b. We're talking curves, buddy. We're not talking about this. We're not talking about this or this. We're talking about this. Still don't get it? Preston, are you being for real with me? I know you dropped out a little bit ago, so can I bring you back? "69-second timeout for you, young man. 69 seconds. All right. Let's talk about this one. Well, it's going to go down 3, right? And it's going to go to the left 1. Remember, it's the opposite sign. Watch out for that, okay? Parent function is y equals 2 to the x, right? And we know what that does. 0, 1, 2, 3. That's the powers of 2. 1, 2, 4, 8. Now, that minus sign, what's that going to do to it? That minus sign out front. Well, let's see. If it's a negative 2, and we're multiplying it by itself a lot, right? So we have, oh, careful. All right. So, guys, there is a difference between this and this. Okay? Let's talk about this. Okay? This says 2 to whatever power you want, and then you negate it. So the answer will always be negative. Always. Because you do whatever you want, and then it makes it negative. This is saying negative 2, and then you're going to multiply it however many times you want. Well, if we multiply it by itself once, it's just negative 2. If you do it times itself twice, now it's positive 4, right? Because a negative times a negative makes a positive. So there's a difference here. This is do everything you're doing normally, and then make it negative. So if this is minus 2, right? Let's do this. Plug in 0. This is algebra. Plug in 0 here. That's 2 to the 0th. Ignore the negative for now, right? 2 to the 0th is 1. Then we make it negative. 2 to the first. 2, make it negative. 2 squared. 4, now make it negative. 8, now make it negative. You see the difference? If it was wrapped in parentheses, then we would do negative 2 to the first, which is negative 2. We do negative 2 squared, which is positive 4. We do negative 2 cubed, which is negative 8. See how it would cycle back and forth? Let's write that. Negative 2 to the 0th is 1. Negative 2 to the first is negative 2. Negative 2 squared is 4. Negative 2 to the 8th is negative 8. Do we see the difference between these? Yes, I will. You'll have to probably vote. I'll send out an email when you're voting, when it's time to vote. So, Olivia, Preston, Shambaugh. Do we see the difference? 2 to the x is this. Negative 2 to the x is 2 to the x, but negative, right? Negative 2 to the x goes back and forth. Negative 2 to the 0th is 1. Negative 2 to the first is negative 2. Negative 2 squared is negative 2 times negative 2, which is positive 4. Negative 2 cubed is negative 2 times negative 2, which is positive 4, times negative 2 again, negative 8. So watch out for those parentheses. I'm going to pause for station identification. We see the difference between 2 to the x, negative 2 to the x, and quantity of negative 2 to the x. This is not a sign. I know, I'm asking you now. Olivia, still with me? It's okay if you're not. All right. So this is going to be shifted down 3 and over 1, but it's going to be made negative first, right? Or I'm sorry, not made negative first. It's going to have that all happen, and then it's going to be made negative. So what does that mean? It's the same thing here. When 0 gets us 1, right? Then we're going to shift it down 3 into the left 1. So I go 1, 2, 3 down, and to the left 1. Then I'm supposed to negate it. Well, I'm already at -2, right? So if I negate that, I get +2. It flips it up. I'll do that again. I'm supposed to be at 0, 1, right? 0, 1. But I go down 3 and over 1. Down 3. 1, 2, 3, and over 1. But then I'm supposed to negate it. If I negate something, it flips it up and down. I'm already at -2, which means if I negate it, I'm at +2. Are we good with that? That's what that negative does. It flips it vertically. This is our vertical flip. We have a vertical shift, which moves it, right? We have a horizontal shift, and then we have a vertical flip. Preston? 1 normally gets us 2. So 1, 2. I'm supposed to go 3 down and 1 over. 1, 2, 3, and 1 over. Then I flip it here. Okay? I normally get 2, 4. 2 gets us 4. I go 3 down and 1 over. Then I flip it. Since it's already up here, I flip it this direction. So it's going to go here. Let me make sure I did that right. 2, 4. 3 down, 1 over, flip it to here. Yep. Three, 8. 1, 2, 3, all the way up to 8. I'm supposed to go 3 down and 1 over, and then I'm supposed to flip it. -5. Now here's the problem. Here's the problem. This should be the same as this, but it shifts it down 3, right? Moves everything down 3. So my asymptote should be here. Do you see how this dot went below it? That doesn't make any sense. So what did we do wrong? This is going to happen to you. I guarantee it. You're going to have an asymptote here, and you're going to be doing your math, and you're going to flip it, and you're going to go, wait a minute, how can I connect those dots? I'm not allowed to go past the asymptote, right? It's going to happen to you. Every time I've done this example, I've done it this way to show you what's going to happen to you. It will. What did we do wrong? What we want to do is we want to flip first. You see what I'm saying? So I normally get 0, 1. 0, 1 is normally what I get. If I flip it, I get -1. Then I'm supposed to go 3 down, 1, 2, 3, and 1 over. So I'm going to do in blue what we actually do. Okay? 0, 1. Right? Is what I'm supposed to have. Flip it first this time. Then go 3 down and 1 over. 1, 2. 1, 2. Right? What I'm going to do is flip it first. -2. I'm going to go 3 down, 1, 2, 3, and 1 over. 2, 4. Flip it first. 2, -4. I'm going to go 3 down, 1, 2, 3, and 1 over. 3, 8. Flip it first. 3, -8 is what I have now. Then I'm going to go 3 down, 1, 2, 3, and 1 over. This makes more sense. It's going to get really close to here, but not quite touch it. Normally my graph would go like this, right? But because of the negative, it flipped it this way. Are you smelling what I'm stepping in? It will happen to you. Think about your math. Okay? No? Shamba? All right, so Shamba, you just came back. I had an appointment, I understand. 2 to the x looks like this. 0, 1, 1 gets us 2, 2 gets us 4, 3 gets us 8, yeah? -2 to the x means 2 to the x and then make it negative. 0, 2 to the 0th is 1, then make it negative. 1, 2 to the first is 2, then make it negative. 2, 2 squared is 4, then make it negative. 3. 2 cubed, that's 8, then make it negative. Okay? This says take negative 2 and multiply it by itself a bunch of times, right? So negative 2 to the 0th is 1. Negative 2 to the first is negative 2. Negative 2 squared. That means times it by itself, right? So negative 2 times negative 2 is positive 4. We see the difference there. This was negative 2 with no parentheses. This is negative 2 with. Cubed. Negative 2 times negative 2 is positive 4. Times negative 2 again is negative 8. Okay? We see the difference there? Okay. 2 to the x would be something like this, right? We've graphed that a bunch of times. Negative 2 to the x, what it does is 0, negative 1 is what you start with. And 1, negative 2. And 2, negative 4. And 3, negative 8. It flips it, right? Normally we get this. But those points, if I graph them, I'd get this. Right? So what it does is it's a vertical flip. It flips it up and down. So here's our original graph. It moves it down 3. So asymptote at negative 3. I took my regular points, 0 and 1, right? Or 0 and 1, and I flipped it. Then I move it 3 down, 1, 2, 3, and 1 to the left. My original points are 1, 2. 1, comma 2. I flip it, 1, negative 2. I move it 3 down and 1 to the left. My original points are 2, 4. I flip it, 2, negative 4. I move it 3 down and 1 to the left. My original point is 3, 8. I flip it, 3, negative 8. I move it 3 down and 1 to the left. Is this making sense? I don't remember how much you missed, Shamba. You might have missed a lot. Did that not make sense? Because if you didn't, I think I know why. Kinda. Okay. I think what you missed was this. Number 6. See how it has a -1 there and a -2 there? The -1 means we move everything down 1, right? The -2, we do the opposite of that. It moves it to the right 2. So here's my regular function, 2 to the x, right? This is what I would expect from it. It's going to do the same thing as this, except it's going to move 2 to the right and 1 down. So instead of 0, 1, like I would expect out of my regular function, I'm going to go 2 to the right and 1 down. Instead of 1, 2, like my regular function would do, this guy is going to go 2 to the right and 1 down. Are you smelling what I'm stepping in there? Is that better? We're looking at the parent function. Instead of having to plug stuff in and figure it out, because that can get you some gross numbers, we're just shifting it over using this. Yeah. So this guy, 3 down, 1 to the left, because it's the opposite direction, yeah? It's opposite of this guy. What does the minus sign do? Well, it flips the whole graph, okay? So normally, my graph would look like this, right? But it's going to flip the whole thing, so it flipped it upside down. Are you cool with that? Yeah, I think you missed that last one. Yeah? Awesome. Rad. Sick. So, goes to as far to the left as it wants and far to the right as it wants. So, domain, all real numbers. Guys, it's always going to be all real numbers for the domain. Right? Range. Y can be any number at once. However, what can't it be? It can't go above -3. It can't go above -3. Right? So it has to be less than -3. Are you smelling what I'm stepping in? I'll take sure for now. Ocho. This is going to shift it down 3, right? So our asymptote normally is at 0, but it's going to go down 3. So our asymptote's now here. Cool. What about that fraction? How's that going to change things? Well, when I plug in 0, a half to the 0th power, right? This is our regular function. Whoops. Okay, I'm not worried about the minus 3 right now. When I plug in 0 here, a half to the 0th is 1, right? So 0 gets us 1. Okay? Oh, sorry. 0 gets us 1. Let me write that down here. Because that's my basic function, right? I'm not worried about the minus 3. Are we cool with that? Okay. So here's my basic function. Y equals a half to the x, right? I'm not worried about the minus 3. I'll take care of that later. If I plug in 0, a half to the 0th is 1. If I plug in 1, a half to the first is a half. If I plug in 2, a half times itself. Right? That's what a half squared is. A quarter, right? It looks like as the numbers get bigger over here, they get smaller over here. If I put a 3 there, 1 cubed is 1. 2 cubed is 8. All right? So these numbers are gross. Because now I got to subtract 3, right? I got to move it down 3. That's gross. That's gross. Let's pick better numbers to start with. When we have a fraction, we don't want to start with positive numbers. What we want to start with is negative numbers. Let's plug in negative 1. What's a half to the negative first? 1 over 2, right? But you're going to flip it. 2 over 1, 2. Half to the negative second. It's a half squared. That's a quarter, right? But then we flip it. 4. A half cubed. That's 1 over 8. But we flip it. 8. Ah, those are nicer numbers to deal with, aren't they? So if you look, at negative 1, I would normally get 2 for my parent function. But it's going to move it down 3. So instead of going negative 1, 2, I'm going to go negative 1, 1, 2, 3 down, negative 1, negative 1. Negative 2 normally gets us 4. But we need to move it down 3. 1, 2, 3. Negative 8, or negative 3 normally gets us 8. But I gotta move it down 3. Remember when we did these numbers? That kind of looks weird, right? These 3 dots right here, ignore this one. This one's a bad one. When we plugged in 0, we got 1, right? And then we have to move it down 3. 1, 2, 3. So it looks like we're going to get closer and closer and closer. Oh, man. So it's going to get closer and closer and closer going this way, right? And never touch this line. So it kind of flipped it this way, right? Normally our graphs go like this. It flipped it horizontally. So when this is a fraction, it flips it horizontally. The regular graph would go like this. This is algebra, yep. But because this is a fraction, it's going to flip it this way. It's going to start out big and get small. Whereas normally when it's a regular number, it starts out small and gets big. That's all. That's all a fraction does. To make it easier to graph, use negative numbers, right? Because fractions, when you take them to a negative power, will flip. How do we feel about that? Oh no. Please don't surprise me. Guys, I have 13 more hours to go on this. 13 more hours of being awake. So, just real quick to recap, because I know some of you guys might be confused. You're taking a little while. My regular function, I'm going to plug in negative numbers because it's going to flip it and make it nice numbers. That's what I did. Thank you. No, not 14. Oh, it is 14. Oh, no. I keep looking at that and thinking that says a 12, but it's not. It's 1102. Okay. Thank you. Math is hard. All right, so I use negative numbers when I plugged it in here, and it flips it, right? And then I go down 3. So instead of negative 1, 2, I go down 3, and I'm here. Instead of negative 2, comma 4, I go down 3, and I'm here. Instead of negative 3, 8, I go down 3, and I'm here. So my curve is going like this. Oh my god. Haberman. Ethan with an E? Do your parents know they spelled it wrong? Do you want me to tell them? I'm a teacher. I can tell them that. They'll respect me. KT Farms. Hey, what's up, man? Haven't seen you in a while. Olivia, Preston, Shambaugh. Who we got? What we got? We're good? Chunky chickens. Oh my god. Yeah, this is the last day of the quarter, boys. The last day for kids to get their crap together. All you virtual farmers out there that have been too busy virtually farming to go to school, and I understand it, right? Someone's got to make the virtual food. Someone's got to put virtual food on the table. Now's the day for them. Now's the day for them. Hey now. Hey now. Right? Hey, I'm just trying to be there for them. Shambaugh, we're good. We're good. We're Gucci. We're Gucci. No, you don't want to learn math. You guys are done with school. Why would you be here? Only nerds show up to this. But yeah, we're doing a 24-hour stream to get all those virtual farmers and other people that didn't do school during the regular quarter, right? Because of whatever reason. They're all valid. That way they can get the stuff done, and then I can put grades in the grade book and go to sleep. Haven't been in school since 2017. Dude, here's the thing. I'm a teacher. I'm never going to stop going to school. Kind of sucks. I'm all about learning. I'm not all about school.
Your words, not mine.
School kind of sucks. Your words, not mine. That's right. Why are you streaming math? Okay, so everybody else in the world is using Zoom, but Zoom is like a piece of crap, right? It's a piece of crap. Excuse me. You also can't do like picture-in-picture with that and all this other cool stuff, right? I don't want to hold up a whiteboard and say, okay, kids, now here we go. All right, no. I want to do this. Also, it's way more fun to meet cool people. Yeah, probably. Probably. But yeah. I don't want to do Zoom. When they first started Zoom and they're like, oh, we're going to do school on Zoom, I'd never heard of it. My kids had never heard of it. Why would I do that? 2 weeks after we start using Zoom, they could be like, actually, our servers aren't big enough. We can't handle everybody in the world doing it, right? And then we're screwed. So I was like, no, we're going with what my kids know. I got them ahead of time before coronavirus scare happened, right? I told them, if crap goes down, and I think it will, here's the plan. And so Twitch is what we knew. Pay raise, dude. Here's the thing: I'm not even getting paid right now. I stopped getting paid technically last week. I'm technically on summer vacation, right? I'm doing this because these bozos, not bozos, sorry, virtual farmers. These virtual farmers that are the heart and soul of America, or at least online America, right? They couldn't go to school during coronavirus, couldn't attend a single class because they're too busy making virtual food, you know, doing the hard work for us virtual people. So I'm here just trying to give back. My friend was in his Zoom class for college and gave me the password to the room, so I joined, and the teacher 20 minutes to realize I was in there, and he wouldn't give me credits. What? Yeah, man. See, a lot of that isn't about education because you're still learning. They just want to make their money. It's all BS. And as soon as they figure out how they can make this money on here, right? They're like, oh, you can have 100 kids all learning at once from one dude. They'll pay the guy the same amount of money to teach 100 more kids. Of Nelk? No, I haven't. Master DTM 12. No, I haven't. I had a student named like Nevin Velk or something like that. Yeah, that's what we're rocking. Yeah, school could be a lot better. It really could. It makes people feel like they're dumb because they can't memorize crap that doesn't matter. And honestly, that's not what it's about. It's about learning how to learn. That way, no matter what the future holds, you can figure it out. Instead, we have them memorize stuff they're never going to use. All right, Olivia, are we good to go on this? Are we feeling okay? Are you still here? Before we got... Yeah. And honestly, like if we try to teach you skills like, oh, teach us how to do our taxes and stuff like that, here's the problem. Tax code's going to change. You know why it's complicated? Because people want it to be complicated. That way they can get paid money to do it. Right? So we don't want to teach you that stuff either. What we want to do is teach you how to think and how to learn. That way you can change the fucking tax code. Right? That's what we should be teaching you guys. Can I teach you science? I don't know. My dad was a science teacher for like 30 years. I don't know. So yeah, we don't want to be teaching you the skills too. Like everyone thinks like that's the cool thing, right? Cool teachers are like, yeah, we're gonna teach you skills. They're gonna screw you over anyway, right? Really, it's these corporations that want you to teach us want us to teach you skills. That way, they have free job training on the public dollar. We just teach you how to think. That way, you can change the world, change the tax code, change who's in charge. Preston pass? I don't know, guys. I don't even know where Preston is. I heard he cheated. No, he didn't even try to cheat. Again, I don't mind if my kids cheat. I just want them to be smart enough not to get caught. Because as soon as they get caught, I got to do extra work. Problem is that the kids that need to cheat aren't smart enough not to get caught. And the kids that are smart enough not to get caught don't need to cheat. All right. Algebra kids, are we good to go with this? Are we seeing what's happening here? Are you smelling what I'm putting down? Because I'm ready to move on to another one. All right, so check it out. We know the parent function for this is going to be y equals a half to the x power, right? Okay, think about it. Think about what this means. So the regular guy, super easy to do math with, right? We plug in 0, we get 1. We plug in 1, we get a half. We plug in... Actually, let's plug in negative numbers. We plug in negative 1, we get 2. We plug in negative 2, we get 4. We plug in negative 3, we get 8. We cool with that, right? The negative means flip it. 1 over 2, 2. A half squared is a quarter, but then we flip it. 4. A half cubed is 8. An eighth, but then we flip it, right? 8. That's the parent function. We know that the minus 2 and the plus 1 here, plus 1 is going to move it up 1. The minus 2 is going to move it to the right 2, even though it feels like it should move to the left. So it's going to be the same thing here, but just moved over in that direction. But here's the thing. What about this thing? How's that going to screw us over? Well, we learned last time that if we have a minus in front of there, we had to flip first, right? We don't have a minus now. We got a 3. So we got to do that first. So what we're going to do is we're going to do the same thing here, but we're going to times it by 3, and then we're going to do that. So check it out. Don't plug in numbers to this. It's a waste of time. You're going to get fractions. Nobody likes them. It's garbage. here's what we're going to do. 0, comma 1 is what we normally get. Times it by 3. That's 0, comma 3. Right? Up 1 over 2. There's your point. This guy. Negative 1, 2. Times it by 3, we get 6. Move it over 1, up 1 over 2. We're here. Negative 2. What's up, J. Reed? Negative 2, 4. We're going to triple it. Negative 2, 12. Oh my god. Move it up 1 over 2. I think you see where this is going, right? Alex did not finish the 5 review. No. So we got this curve here, right? I'm not playing. Shamball, what's the asymptote? What would our asymptote be if it moves it all up 1? Where's the line we do not cross? Exactly. So all we got to do is sketch it, right? Looks like that's our curve, boys. It's going to get really close to the asymptote, but it will not cross it. Well, I'm awake until 1 p.m., man. He's the one that waited till the last day. I'm letting democracy rule here. Democracy. All right, so that's our graph. That's it. What would you use it for in real life? Great question. Real quick and I'll answer it, okay? Give me a second and then I'll answer that. That's a great question. 2 things. 1, a bullshit answer, and 1, a real answer, okay? Range. All possible values, left to right. All possible values, except it has to be greater than 1, right? It's above 1. Questions on this, Algebra kids? All right, couple things. 1, let's talk farming, okay? When you're setting up for your water, like automatic watering, you have to set like how you want it to move on a field. If you're going to program that, you'd need that. That's kind of my bullshit answer, okay? Another thing you might do, virus growth. This is decay over time. Exponential growth is how populations grow and viruses grow, so you can track when that's going to be like deadly and when it's not. Try to figure out when to send people back. That's bullshit answer number 2. Actual answer, you're not. But here's why we learn it. Because math is a good way to make you think differently about stuff. Could you just plug in numbers and graph it? Sure you could. But if you think differently, think cleverly, what does it mean? Then you expand your brain and you learn how to learn. And that's the most important thing. Because then whatever you want to do with your life, whatever you need to do, no matter what the future holds, you've learned how to learn and think differently. And you can figure stuff out for yourself. That's why we do it. You're never going to use any of this crap. You're probably not. But that's not the point. At least it's not the point in my class. Everybody else is trying to make you memorize this and how to do stuff. And here we learn how to think about it. I do not have my kids memorize anything. You just have to know what it means. Why is it moving up 1? Because if I think about that in my head, it will move it up 1. I can check it, right? I know what this means, and so instead of getting really awful fractions, I can just do that, and I'm done. It's thinking differently. When you get a tough problem, how to make it an easier problem. That's a skill you use the rest of your life. And I use math to teach that. That's all. Right? If I was paid to teach English, I'd do the same thing. But I'm paid to teach math, so I teach math and teach kids how to think differently. I'm not about grades. You heard from Preston. He only has to pass 2 quizzes. In order. Not about grades. About can you think differently? If you're going to cheat? Great. Just be smart enough not to get caught, right? That's thinking differently. So I don't know. Could you use this? Sure, maybe, right? But that's not the point. That's not the point. I don't know. You want real life examples? 10. This is real life. Can of Mountain Dew. 54 milligrams of caffeine. It's true. It's true. I don't have any cans near me because I'm all out of cans. I'm on this guy now. Don't you wish all Mountain Dew bottles look like this? That's sick. Reflector white. Why don't they make it like that? 54 milligrams of caffeine. The average person can eliminate approximately 10% of the caffeine in their body per hour. Okay? Replace Mountain Dew with whatever beverage you want. Replace caffeine with whatever additive you want. Okay? How much caffeine will remain after 4 hours? We'll check it out. Let's think about this. If we're starting with 54, right? 10% goes away in an hour, right? So that means 90% will be left. Well, how much is 90% of 54, right? 0.9 times 54. When we say of, we mean multiply. 90% of 54. That's after 1 hour. 90% will be left over, right? 10% is gone, 90% left over. After 2 hours, how much is going to be left? Well, that's after 1. 90% of that will be left over. So 90% of that will be left over. After 3 hours, this is how much is left after 2. After 3, 90% of that will be left over. Are you smelling what I'm stepping in here? There's an easier way. There's a formula we can do here. Repeated multiplication, right? That's exponents. 0.9 times 0.9 times 0.9, that's just 54 times 0.9 cubed. This is 54 times 0.9 squared. This is 54 times 0.9 to the first. You see? However many hours go by is how many times you time it by 0.9, right? So there's your formula. You want 4? Plug in 4. 0.9 times 4, or 0.9 to the fourth. Take 0.9 every time. What is this going to look like? Well, check it out. 54. What's 90% of that? 48.6. 90% of that. 90% of that. 90% of that. Yeah, man. So after 4 hours, you're still going to have 35 milligrams in your body. That's not even half, right? That's the answer. Your answer was rounded, right? If you want, you can get out a calculator and do all that. But who cares? If you need a calculator to do it, I'm not testing the calculator, right? Odds of you typing it incorrectly, do you know Preston? Come on, right? He's going to get some answer and I'm going to be like, how in the what? But if he shows me this, right, and he circles that, I know he's right. I know where he got it from. That's thinking differently. Don't type it in. A lot of these answers you're going to have to round, right? Which means they're not accurate, right? That's 100% accurate. It's exactly what the answer is. If you round it, that means the answer didn't need to be specific anyway. Well, if you don't need a specific answer, isn't that just as good? Right? There's two options. Either you don't need a specific answer, and that's great. Or you do need a specific answer, and that is literally the best you can do. Pritzker? No, I didn't. Now, a normal teacher would teach you a formula, and this is what the formula would look like. Starting number, the difference in the rate, t. And that's how much is left over. And you would be expected to know what this means how, right? But that's it. Property tax scheme? Yikes. That's no good. Another lefty bites the dust. And by lefty, I mean liberal. They do the exact same thing as Republicans do, but they're not smart enough not to get caught. Or at least not smart enough to convince people that it doesn't matter, right? Someone like Pritzker does it, and he can't convince everybody that it's no big deal because they're already against him. Somebody like Trump does it, it's like, it's no big deal, right? And people believe him. Again, I'm not saying don't get in trouble. I'm saying don't be smart enough not to get caught, right? That's all I'm saying. The people that are really doing the right thing aren't in power. right? And that's not an accident. I'll check it later. How do we feel about this? Olivia? Preston? Shambaugh? Preston, you feel good about this, right? Again, I can teach you the formula. You can just think about what it means, right? Teaching the formula is a waste of time. You're never going to use that in your life, right? But thinking about what it means, good exercise.
No.
Jerica, what are you doing here? How long have you been here? Doesn't even say you're in chat. Thanks for the follow, Chunky. What a freaking nerd. Oh, right. I didn't. I just say that. I didn't realize it said it up there. I forgot. 11. I'm so bored. This girl gets done with school early because she gets it done on time, right? It's like, I have to get it done before Monday. I have to. And now what is she doing? She's here anyway. And I stayed up super late to make sure she got stuff done. We're almost done. We got one more. We got one more, guys. Danny, what are you doing here? Oh my god. Seriously, you're done. You graduated. I passed you, so I'd never have to see you again. Guys, I'm done right after this. This last problem. Mr. Matt bought a car in 2015 for $24,000. This is true. The value of the car. What an asshole. The car decreases by 20% each year. What is the value of the car now? Let's think about this logically, right? It starts at 24, 000. How much is left after 1 year? 80%, yeah? 80% of 24,000. What after 2 years? Well, 80% of that. How many years has gone by since 2015? Feels like 100. But in actuality, how many years have gone by? I know, it feels like 1,000, right? But it's been 5. So we're going to take 80% of that 5 times, right? As soon as you get that car off the lot, time starts ticking. That's capitalism, boys. So, 24,000 times 0.8 times 0.8, that's 2, times 0.8, that's 3, times 0.8, that's 4, times 0.8, that's 5. Your boy's car is only worth $7,864.32. If you needed it exact. But let's be honest, right? That's not going to be the exact amount. That's not good. 24,000 times 0.8 times 0.8 times 0.8 times 0.8 times 0.8. That sucks, man. 20% depreciation. That's pretty generous, too. But here's the thing. Is this a realistic model? Let's think about that. Is that a realistic model? Why or why not? Why? Car? Chevy Sonic. It was when I was touring. I was in a band. I needed lots of room, but also good gas mileage. So I did some math, and that was the best buy. Kinda. Why isn't it? Is the car new? It was when I bought it. 2015. Sonic's alright. No, I couldn't afford a Honda Civic. Not that I want one. Doesn't have very good room. Chevy's a no-go. I'm a big fan of Chevy. Dude, the Camaro's a classic. You kidding me? Like, how can you say no to that? So think about this. My grandfather, right, gave me a 1987 Ford Ranger. Red interior. Used to drive to the lake all the time. Smelled like him when he died, right? Small truck, right? 1987. I used to drive this around when I was doing deliveries. Transmission fell out, right? Pulling in and out of driveways. And so, oh, hey, pedal. I'm driving around doing deliveries. Transmission falls out. Got to get it towed. Now, my grandmother, who is still alive, right? My grandfather died. She was pretty sentimental about the truck. But the thing is, she also had dementia. Still does. And so, when they towed it 6 hours south to bring it back to her, and I paid for it because I knew that she would want to keep the truck, her dementia, right? The guy driving that truck down there was like, "Hey, I'll pay you $300 for it," and she's like, "Oh, okay." I paid $1,000 to get it down to her, right? The guy bought it from her for $300. Why did he buy it? Why would he want an old car like that? Isn't it supposed to depreciate, right? 1987 was a long time ago. Why did he want it? Why was he willing to pay $300? This isn't an accurate model. It wouldn't make any sense, right? Because if you wait long enough, if t gets big enough, the time gets big enough, right? Enough years go by, what happens? That price stops going down and it starts going back up. So if you wanted to write a real model that factors that in, maybe after t is 30, right? Then you find a way to mathematically shoot it back up. Figuring that out's problem for another time. All right, so that's it for the algebra review. Olivia, Shambaugh, Preston, are we feeling good enough? Feeling good enough? Because I want to take like a 3-minute break, and I'm gonna post a poll right now. I'm gonna post a poll right now. If Olivia's good, I think Olivia dipped a while ago. I can't see all who's in chat. I need to refresh this thing. Anyway, I'm going to post a poll for what we're going to do next. If you are not going to be here for that quiz, do not vote. I know some of you guys are like, I want to help out Preston or whatever. That's awesome. But I need to let democracy reign. And you guys are not Mr. Max citizens. Sorry, you're not. So you can't vote. Can't vote. Well, yeah, I'm going to take a little bit of a break while I put this up. Okay, we got a 20-minute break. Timer's up here, right? Vote for the next one that you want to do. I'm going to send out an email to let kids know that I'm reviewing that.